Hello students, in this video I would like to discuss about dynamic programming. Dynamic programming, like the divide and conquer method, solves problems by combining the solutions to subproblems. Divide and conquer algorithms partition the problem in independent subproblems, solve the subproblems recursively, and then combine their solutions to solve the other subproblem. So we already discussed about divide and conquer algorithms in one of the previous video. In contrast, dynamic program is applicable when the subproblems are overlapping or not independent. That is, when subproblems share subproblems. So, dynamic programming can be considered as a type of divide and conquer algorithm. So, we already studied divide and conquer algorithm. There we divided larger problem to smaller subproblems. Here in dynamic programming also we are dividing a larger subproblem into smaller subproblems. Here we have one more property, that is the subproblems are overlapping or same subproblems are arising. So when same subproblems are arising, we need to solve the subproblem only once. So dynamic programming is applicable when the subproblems are overlapping. Overlapping means occurrence of same subproblems. A dynamic programming algorithm solves every subproblem just once and saves its answer in a table, thereby avoiding the work of recomputing the answer every time the subproblem is encountered. So here we have same subproblems or overlapping subproblems. So during the first occurrence of the subproblem itself, the subproblem is solved and the result will be stored in a table. So when we solve a particular problem, whenever this subproblem arises again, answer is directly taken from the table. Dynamic programming is typically applied to optimization problems. So optimization means either to maximize the value or to minimize the value. So I will try to explain dynamic programming with the help of an example. Here this example is about determining nth term in a Fibonacci series. So here we have 0th term, that value is 0. First term, its value is 1. Second term is sum of 0th term and first term. Third term is sum of first term and second term, and so on. So here I have the recurrence relation. Fib of n equal to fib of n minus 1 plus fib of n minus 2. And here we have two base condition or anchor condition. That is fib of 0 equal to 0 and fib of 1 equal to 1. So here fib of k is computed once and stored in a table. So we just look at this recursion tree. Instead of fib, here I have denoted as f. F of 6 is actually f of 5 plus f of 4. And f of 5 is again f of 4 plus f of 3. Similarly, it shows all other division of subproblems. So here f4 is computed 2 times, f3 is computed 3 times, f2 is computed 5 times, f1 is computed 8 times, and f0 is computed 5 times. So here we have same subproblem, f4 twice, f3 is computed thrice. Here one f3 is there, here one f3 is there, another f3 is here. So if you apply dynamic programming, we have to calculate the particular subproblem only once. Here if you notice this recursion tree, we can see the overlapping subproblems or same subproblems. So here fib of k is computed once and stored in a table. Later, whenever fib of k is encountered, its value is taken from the table. So next is approaches to solve dynamic programming problems. Two approaches are there, top-down approach and bottom-up approach. So first is top-down approach. In this approach, a recursive call is made with the given problem size, and next call is made with the smaller subproblem where the argument value gets decreased. Further calls will be smaller than the previous ones, just like calls in the Fibonacci series as shown below. So before going to this pseudocode, I will discuss about this pseudocode. This is a normal recursion. So if n is less than 2, result equal to n. That means if n is 0, result is 0, or the 0th term is 0. If n is 1, first term is 1. So the n value will be the result. and that result will be returned. Otherwise, we are making a recursive call. Fib of n minus 1 plus fib of n minus 2. So this is the normal way in which we estimate nth term of Fibonacci series using recursion. So now you look at the left hand side. Here we have an array called MEM. So whenever a particular subproblem is solved, its value will be stored in the MEM array or memory array. So later, whenever the subproblem occurs, that value, the value of the subproblem will be taken directly from this array. So these steps are executed only when this MEM of n is not in table. That means this MEM of n value is nil. So here the same recursion is written here also, but the result is stored in the array or in the table. So these recursive calls are made only when that particular value is not in the array. So here this is top-down approach because the first call is made in the largest subproblem. The first call for in the earlier example, fib of 6 is called first. So it will call fib of 5, then fib of 4. The argument value get decreased. Here it is n, here it is n minus 1, here it is n minus 2. Again, next time also when these calls are expanded, the argument value will get decreased. So in top-down approach, we are using recursive call. So it is also known as memoization. Next approach is bottom-up approach. In this approach, rather than beginning with the main problem, start solving with the smallest one and on the way increase the subproblem size through using the computed subproblems. It is based on iteration rather than recursion. Earlier in top-down approach, we used recursion. Here we are using iterative method. So we all know 0th term of a Fibonacci series is 0. First term of a Fibonacci series is 1. So in the table, those two values are initialized. Then I am executing a for loop in which the for loop executes from index value 2 to n. That is MEM of 2 equal to, or the second term of Fibonacci series is MEM of I minus 2, that is MEM of 0, plus MEM of 2 minus 1, that is MEM of 1. So when I equal to 2, the cell with index value 2 will be filled. Similarly, when I equal to 3, cell with index value 3 will be filled, but using the value in the cell number 2. So in the end, it will return MEM of n. So it is also known as tabulation. I hope you understood the concept of dynamic programming. Thank you.